This is section 5.1.3, problem solving with the GCD and the LCM. Here's our first example. A choral director needs to divide 180 men and 144 women into all male and all female singing groups so that each group has the same number of people. What is the largest number of people that can be placed in each singing group? Now that we've read the problem and understand what they're asking, we need to ask ourselves, do we find the GCD, the greatest common divisor, or the LCM, the least common multiple, in order to solve this problem? You'll recall that the GCD is the biggest number that goes into two numbers, and the least common multiple is the smallest number that those two numbers go into. So in this problem, since the choral director needs to divide the men and women into smaller groups, we need to find the greatest common divisor of 180 and 144. So let's do this. 180, 144, we're finding the GCD. We remember from the previous video that the first step is to find the prime factorizations. So, 2 times 90, 2 is prime. 2 times 45, 2 is prime. 5 times 9, 5 is prime. 3 times 3, prime. So our prime factorization of 180 is 2 squared times 5 times 3 squared. Now we do it for 144. 2 times 72, 2 times 36, 2 times 18, 2 times 9, and 3 times 3. So the prime factorization of 144 is 2 to the 4th times 3 squared. Okay. Now that we have the prime factorizations for 180 and 144, we need to find the GCD, the greatest common divisor. And if you remember the two steps for doing this, the first step is doing the factor trees and finding the prime factorizations. We've done that. Now the second step is to take just the common factors. So the common factors that we see here, there's a 2 and 2 and 3 and 3. So we have our common factors, but if you remember, we want the common factors with the smaller exponents. So 2 squared is smaller than 2 to the 4th, so we're going to use 2 squared. And 3 squared and 3 squared, there isn't a smaller exponent, so we use 3 squared. So 2 squared is 4, 3 squared is 9, 4 times 9 is 36. So what this means in the context of the problem is that the choral director will need to divide the men and the women down into groups of 36 men and 36 women. So if we take 180 divided by 36, there will be 5 groups of 36 men. If we take 144 divided by 36, there will be 4 groups of 36 women. All right, let's look at our second example. 2 people are in a bicycle race around a circular track. One rider can race completely around the track in 40 seconds. The other rider takes 45 seconds. If both begin the race at a designated starting point, how long will it take them to be together at this starting point again if they continue to race around the track? Once again, we need to decide, in order to solve this problem, do we find the GCD or the LCM? In this problem, we know that these riders will be going around the track continuously until they meet at that same point again. So essentially, the faster rider will catch up to the slower rider. If you take the 40 seconds and the 45 seconds, that it takes each rider to go around the track, their time will be accumulating as they go around the track. It'll be getting bigger and bigger and bigger. So what we need to know is at what point will the time match up again, or excuse me, at what time will the riders match up with each other again? So what we're going to have to find is the least common multiple of 40 and 45. So let's do that. So we're finding the LCM of 40 and 45. So prime factorizations. So 40, we can do 2 and 20, 2 and 10, 2 and 5. So we have 2 to the third times 5 as the prime factorization of 40. For 45, let's do 5 and 9, because 5 is prime, 3 and 3. So we have 3 squared times 5. All right, now we have our prime factorizations. To find the least common multiple, if you remember from the previous video, we take each factor, and for any that are in common, we take the larger exponent. So our factors, we have a 2, we have a 3, and we have a 5 that's in both. In both, it's 5 to the first power, so that's not going to make a difference for us. So we have 2 to the third times 3 squared times 5. 2 to the third is 8. 3 squared is 9 times 5. 8 and 9 is 72 times 5 is 360. Okay, so let's go back to the context of our problem. The 40 and the 45 were the number of seconds it took the riders to go around the track. So what we're saying now is that after 360 seconds, the riders will be back together at the same point. So let's do this. 360 divided by 40, so it'll be 9 laps for the faster rider, and 360 divided by 45, it'll be 8 laps for the slower rider. All right. So after 360 seconds, which is 9 laps for the fast rider and 8 laps for the slow rider, these two riders will be next to each other again. So you've seen from our 2 examples that you have to read the problem, understand the problem, decide whether to find the greatest common divisor or the least common multiple to answer the question. This has been section 5.1.3.